Planet Girl here today with the third installment on the structure of matter. Matter is anything that takes up space and has mass. It can change phases, and we're going to start today where we have heat in the room. We have a solid, ice. It is a form of water in a solid. We have water in the form of a liquid, and we're adding heat to both. Room temperature heat to the ice and high temperature heat to the water. We'll see what happens to this matter as it changes phases. The law of conservation of matter states that matter cannot be created nor destroyed. It just changes form. It can be found in 5 different phases. Your parents probably learned that there were only 3, so you can show off and tell them how much more you've learned. The 3 commonly known ones, they're also known as states of matter, are solid, liquid, and gas. Water in the form of a solid is ice. In form of a liquid, it's just regular old water. And when it gets really moving fast, those are the molecules, that is, are gas. Do you really think they're all the same compound? That's H2O. Solids are usually hard because their molecules have been really packed together. They hold their shape, and it's because the atoms don't really move around. They're stuck real close together in a specific arrangement. However, they will still spin and the electrons still float around the nucleus, but it still will not change position. They can be pure elements, compounds, or mixtures. Here you can see the molecules in the solid. See how squished together they are? They can hold their shape. Gold, salt, and concrete are forms of a solid matter. Liquids, they flow more because their molecules are not as tightly packed together as in solids. They kind of move around more, but a lot less than molecules in gas. Blood and water are examples of liquids. You can see they have more space to move around. Liquids can fill up a container, but they're very difficult to compress. Liquids can also be found as pure elements, compounds, or mixtures. Gases, the molecules are really spread out and the atoms are full of energy. They're bouncing around constantly, kind of like 6th graders. Gases can fill a container of any size or shape. Gases are found everywhere and usually easily identified in the atmosphere. Oxygen and carbon dioxide are gases. Remember, oxygen is what you breathe in to live, and carbon dioxide is the gas you release. Look at how the molecules are so spread out in a gas. Here you can compare solids with the compact molecules, liquid. They've got a little bit of more weight. They can move around a little bit better. And gases, they're all over the place. This is the difference in the atoms in the different phases of matter. Remember, we're using atoms and the word molecule kind of interchangeably. Then there's the 4th state of matter. Remember, I told you can show off to your parents. They probably might not have heard of this. It's plasma. It doesn't usually occur naturally on Earth. They're very similar to gases, but they're different because they have free electrons, and they're only found in elements such as neon. You can find them in fluorescent light bulbs, neon lights, and in the stars. Here's a comparison. You can look at the difference of the atoms in the different phases of matter. Again, the solids, the molecules or atoms are compacted together. Liquids, they can flow a little bit more because they have more space. Gases, they're bouncing everywhere, and you can see the neon of the plasma where they're moving even more than gases. And these phases change when you add heat. So the states of matter can go from one phase to the next. Wait! We've got one more, and I guarantee you can wow your parents with this one. It's the 5th state of matter. It's Bose-Einstein condensates. That crazy name came because it's named for the 2 scientists who originally predicted this phase of matter. However, it was back in the 1920s and they really couldn't provide evidence when they did their experiments to support their theory. But then two other scientists, Cornell and Wyman, figured out a way that they could actually have evidence to show that these Bose-Einstein condensates existed. It was not till 1995. The BECs are created only when a few elements are extremely low temperatures. The temperatures are so low the atoms kind of clump together in a superatom or a blob, and that's the BEC. So a phase describes a physical state of matter. Matter can move from one phase to another, but only by physical means, and it's still the same substance. This is called a phase change. So if you add heat energy, or if heat energy is taken away, a physical phase change occurs. Well, remember back at the beginning, we had water, and we were seeing if we could see if a phase change would occur. Hold on one second, and here we go. While we were talking, our liquid is turning to a gas. See here, please remember that we are using proper safety equipment. We do not touch anything with heat, but the liquid is changing from a liquid to a gas. It's evaporating. Our ice is still partially solid, but you can see where it's turning to a liquid. Our solid, because of the room temperature, added heat and turned it into a liquid. Thanks for watching. Don't try that at home without adult supervision.